Um, welcome everyone. This is Fullstack Speaker Series. I want to welcome Eddie Zaneski. Is that pronounced it correctly? Yep. From Twilio. And it's actually funny, Eddie's speaking here because he saw a Fullstack student give a talk at Queens.js?
Node meetup.
A Node meetup. So I think it was Jimmy and Christian, right?
Yep.
And so he's here because he saw two Fullstack students, thought that their talk was really cool. And we're brainstorming to talk about, and talking about one of our favorite subjects, handling asynchronicity in JavaScript. And we also talk about the Twilio API at all, or?
A little tiny bit.
A little bit. Okay. Twilio API is, I remember it very fondly because I had a friend at Guild who used the Twilio API early on at a hackathon to create what he called then Grouply, which eventually became GroupMe, and which eventually sold for, I don't know.
Tons of money.
Tons of money. So you might also be able to use Twilio API to make tons of money. So without further ado, I'll let Eddie talk. Doc, you're mic'd in.
Hello, hello.
And we'll have questions afterwards.
Okay, cool. Well, thank you so much for having me, everyone. Like you said, my name is Eddie Zaneski, and I'm a developer evangelist at a company called Twilio. We'll talk more about Twilio in a little bit, but I want to get a sense of everyone's class level here, right? So I understand we have like senior levels, and what are the other ones? Junior. So can all the juniors please raise their hand? That's awesome. And the seniors? Cool. All right, so it's a nice split. Quick show of hands. Who came here without knowing to program at all before? Okay. And who had been programming for just a tiny little bit? Okay, that's awesome. So when you came in, who knew JavaScript? Or who had used JavaScript before? Okay, that's not as many as I thought. So the question I have for you then is what made learning JavaScript hard for you? Because I know what made it hard for me, and I'm wondering if we all had the same kind of issues. So does someone want to shout out one of the challenges they ran into?
It's not typed.
It's not typed? That's a good one. Anyone else had?
Well, async stuff.
Async stuff, exactly. Did you have one too? So the asynchronous in JavaScript is actually one of the hardest things to grok, get your mind wrapped around when you're coming into a language. And it's not just in JavaScript, it's in any programming language. Asynchronous is hard because the human brain processes things synchronously. Right? So what I'm here to talk to you about is the evolution of asynchronous JavaScript. So we're going to start at the very basic level of events and callbacks, which I'm understanding that you're all familiar with, and then we're going to ramp up and get into some more advanced and cool stuff. So real quick, we talk about asynchronous, we talk about synchronous. Does anyone really have like a firm understanding of what this means?
Which one?
Synchronous. What does synchronous mean in programming?
It kind of means it happens at the time that it looks like it happens.
Yeah, exactly, right? So it runs a statement or it executes something, and it completes that statement fully before it moves on to the next thing, right? So we have all of our operations. We take like a network request or we take a database read. In a synchronous environment, those requests start. If they take 60 seconds to complete, the program is sitting there waiting for 60 seconds, right? So the technical term we call this is blocking, right? So the program is sitting there blocking for 60 seconds. So it's waiting for this data to come back, and it's waiting for the data transmission to end. And the question is, if this is difficult, right? If asynchronous programming is difficult, why do we do it? And the main reason is because of performance, right? When that program is sitting around for 60 seconds not doing anything, that's a bunch of time that it could be actually doing something, right? It could be moving on to the next operation. And that's why we like things like JavaScript, even though battling asynchronous code can be really challenging, right? So what I have here is a code example, and hopefully you all can see it. This is reminiscent of the first JavaScript code that I ever wrote coming in, right? And I'm sure you've all done something similar before. I go to a lot of hackathons and I work with a lot of beginners and students, and they all come to me with the same kind of example here, right? So if you're looking at this code, we see we're requiring this request library, and then we have a function called getQuote. We define a variable called quote, and we make a request to the Ron Swanson quotes API, which will return us a quote from the wonderful Ron Swanson. And then we have this thing here that we don't really understand, and then inside that thing, okay, we need access to this variable called body, so in here we're just going to assign our variable to body, and then we're going to return our variable, right? So we come down to the bottom, and we run that function, and we're hoping it returns in the quote, and then when we print out quote, what do we get? Undefined, which you can't see because I changed my fonts last minute, but there it is. So right, so it prints out undefined. And why does it print out undefined, right? This is me at my first hackathon back in 2013, and I was just learning JavaScript for the first time, and I had no idea what was happening. Like, how is this possibly undefined? Like, what is going on? Who is being cruel to me right now? And the reason it's undefined is one of, like I said, the hardest things to actually understand when it comes to JavaScript. I tell people that once they master this, they've pretty much mastered the language, because understanding this concept gets you through anything you need to do in the language, right? So, of course, it returns undefined because that's what's assigned to, that is what is in an unassigned variable in JavaScript, right? So we actually define our quote. This happens some point later, right? We're not worrying about that right now, and we return our quote. But this hasn't happened by the time we return, right? So obviously it's undefined. Right, so we're talking about Node, and this is from the Node website. And there's a lot of text on this slide, I'm really sorry. But Node.js uses an event-driven, non-blocking I/O model that makes it lightweight and efficient, right? So we understand what blocking is of I/O, right? It's something we don't want to do, so that's what Node gives us. But what does this event-driven mean? Has anyone played around with event emitters yet in JavaScript? Yeah? That's some fun stuff, right? So we have another example here. And this is not in Node, but this is in the browser, right? So we're taking our document, we're adding an event listener for my event. We're giving it this thing that we're going to talk about in a second, right? This callback function. And then we're telling it to print out the details of that event. And down below, we are dispatching an event, a new custom event with the same tag and the details there. And when this runs, we obviously get back, it's over here somewhere. There you go. I'm an event, right? So it prints that out. And this is how Node and JavaScript work under the hood, right? So if we're in our browser, and the whole reason we need this event-driven system is it was originally designed for the browser, right? So you're immediately going through your browser, you're scrolling around, you're clicking things. If those actions were completely synchronous, there'd be a lot of blocking and a lot of buildup, right? You'd click around, and a bunch of things would queue up because it was completely processing synchronously, and then after whatever it was blocking finished, everything else would happen and your page would explode. So thanks to this event-driven model, we're able to, it was introduced for a reason, because we need it to work with things like user interfaces. So we have another example here, and now we're introducing the callback, right? So that's what we were talking about before. We're all pretty familiar with it. I can't fit it all on the screen. But you get the point, right? So this is how we solve our original problem, right? And this is what I spend the most time explaining and teaching to people at those hackathons. So we have our quote function. We're passing in a function, right, which confuses people right off the bat. But we all know that in JavaScript, functions are first-class citizens, right? They can be assigned to variables. It doesn't actually care. They just get passed around. So this comes in up here into callback. We're going through the same thing, but instead of returning body like we were doing before, inside of our callback, we have our callback called with whatever's passed in from here, right? But what is the point of these callbacks and how do they work, right? So what actually happens when this is done is the JavaScript interpreter inside of Node knows that this request is going to be I/O bound. Right? It uses the native Node APIs under the hood, which are asynchronous. And it is then able to open a socket, start transmitting that data, and it takes whatever you pass it for this callback function, and it pushes into something called the event queue. And the whole time, we have this loop called the event loop that's running, right? Is everyone familiar with the event loop a bit? So it's a really challenging concept to understand. There's a great talk that I'll make sure it gets sent around. It's what finally solidified it to me. But this event loop is running. And the interesting thing is that nothing on the event loop can actually be processed until all the remaining synchronous code is done, right? So have you ever seen someone do like a set timeout for 0 seconds into the code somewhere? And you're like, why would someone do that? Like, you're just setting timeout. It's going to happen immediately. But it's actually a hack. What it does is by setting a timeout, it forces it onto that event queue, and that allows us to call it later after the remaining synchronous code is done. So Everyone with me so far? Not confusing? Cool. And if you have questions, please raise your hand. I don't want anyone to get lost through this. So obviously, when we run this, we're going to see more of a behavior we expect. And we're going to get our quote printed out, which says, any dog under 50 pounds is a cat, and cats are useless. Right? Ron Swanson for you. So that's awesome. Between callbacks and events, right, we're in a happy world. We're partying like drunk Ron Swanson over here and dancing around. And there's no other problems, right? We've solved our asynchronous issues. We're able to do code that's performant, and it gets the job done, right? Has anyone ran into any problems doing like a bunch of callbacks? Yeah?
Well, if you call off a bunch of callbacks at the same time, you never know in what order they will return.
Yeah, right. So this is the problem that I find myself doing a lot. And this code's actually taken from something I wrote at some point. And this is what we call the pyramid of doom, with a little trademark after there, because someone else came up with it, right? So this is Mongoose. Has anyone used Mongoose before? Right, it's the MongoDB database driver for Node. We're grabbing a venue, we're finding one by this request body, and then we're checking if we have a venue, and then we're finding an event that has that venue ID, and then we have that, and then we find a user by the email that's passed in, and then we update and push them into the attendees, right? And this is basic, right? There's nothing complex about this. But you can see that like our code is like indented, right? Has anyone ran into this before? This is awful, right? So we may have solved the problem of doing async with callbacks and events, but it leads to code like this, right? And this is also challenging. This is really hard to look at, especially if you step away. When I first opened up this file to try to find something, it's just like, I don't even realize what's going on at first. Like, this is complex. The code's not complex, but processing it is complex, right? You don't know the order of things when they're executing. So what we want to do is we want to find a way to solve this. And there's a few ways that we've done this, right? So we're in the pyramid. We're looking at our idol that we're going to steal. And the real answer is, how do we get past it, right? Well, there's a few options that we have. So this is probably one of the earliest. I don't know how well known it is anymore because we have better tools in the house. But has anyone used the async library before? Async waterfall used to be the go-to, right? So it was this library that someone wrote. And it's got a ton of different features. It has like parallels, series, waterfall, but like waterfall was the function that you used. And what it does is exactly what it sounds like. You have a bunch of callbacks, and you want to deal with the data and the results from them inside of each other. So you would give it this array of functions, and it would pass in the next one, and you'd call it with whatever you needed, and it would just go through the waterfall effect, right? So this was nice. This was the solution to that problem. It got the job done. It's definitely not the most elegant, but it worked, and it worked for quite some time. Like most of the libraries you used probably have had async in them at one point. So that's cool, right? So we tried to solve problems with libraries, but really we have to. If everyone's trying to solve these problems and everyone's using the same kind of library, there's got to be a better way that we can process it, right? So then came along promises, and I understand that the juniors have done promises for a little bit. Yeah, cool. So promises are a native object inside of JavaScript now. They're in Chrome, they're in Firefox. I think a couple other browsers have implemented them. Node has it out of the box, which is awesome. And this promise is a concept of this object that will give us a value at some point, right? Like, hey, like here's a promise. It's like telling your buddy, I promise I'll pay you back, right? I promise I'll give that back to you. And that's what we're doing here, right? So we have this function foo, and we're returning a new promise, and the promise expects us to give it a function that takes in resolve and reject, which are also two functions. And if we have made a request successful, if we're happy and we want to move on without any problems, we call resolve and we can give it a value. Excuse me. And then, because we're returning this promise, the best part about it was this then that gets exposed, right? Everyone's loving throwing thens around. The promise logo is just the same JavaScript logo, but with the word then on it, right? So it's awesome. We can now call then on foo because it's returning this promise. And if the promise is resolved, it calls the function that's passed into then. right? And in here, we're doing the same thing, returning a promise. But here, we're calling reject, right? Because something bad happened. And then we go down, and we have this other promise, right, that would get called if reject hadn't happened. But we call reject, so it immediately jumps to the catch, right? So right now, we have something cool that we didn't really have before, right? We have error handling. This catch allows us to catch any of the errors that are going to be rejected through our promise chain, right? You'll see in a little bit, we're going to talk about error handling through callbacks. And it gets pretty messy. There's a lot of repeated code, right? So promises are a really important concept. They're really powerful. And they allow us to chain these things together, right? So let's take a look at our Ron Swanson example. And here we're using promises. And here's the same kind of thing, right? Here's our get quote. And we're returning a new promise, and we're calling a request, and if the request is bad, we're going to reject the error, and if it's good, we're going to call resolve in the body, and then we're going to chain it, and then print it out. Right, so what quote did we get back this time? Let's see. Oh, I can't find it. There it is. Crying, acceptable at funerals and the Grand Canyon. Right. Ron Swanson is a man of wisdom. So the next cool thing, right? So promises are rad, but they're not implemented everywhere yet, right? Like, so we can wrap our own things, right? So we go back to the request example, and request doesn't return a promise, but we're really easily able to promisify it, right? That's the term we threw together. So we can promisify request. There's also a promiseified version of request that is wrapped to return a promise, right? So this is nice. We can take any library we used before, and we can make it return a promise. And as we go on, we will see some new APIs and some new functions start to implement these promises, right? Because this is what we want. Promises are the solution that we are looking for. So this is the, has anyone heard of the fetch browser API before? Right? Have you ever tried to do an XHR, the XML HTTP request, and it's like 30 lines of code, and you're throwing around all these other things, you have no idea what you're doing, and you have to look it up every time like I do, or using jQuery's Ajax. But fetch is a native version of the XML HTTP request in the browser. I think it's in Firefox and Chrome right now, and most of the mobile browsers except Safari. But this returns a promise, right? This is awesome. We call fetch on our quote. We pass that in. It returns us this response stream. We call the JSON method on it, which also returns a promise. So we're chaining them. And then we're getting our JSON out, and we're going to print it out. And our quote this time is, there is only one bad word, taxes. So as more things start to implement promises, we're going to have a much better life, right? Like these things are, this is what we want to be working with. This is not going to be the callback pyramid of doom. It's going to be a nice, easy to read, top-down, chained, waterfall almost style processing of asynchronous code. So the next thing we're going to talk about is this concept of generators. And generators are very, very difficult for me to explain. And it would be a very disjustice if I tried to explain how to use them properly. So we're just going to touch on it briefly. We can declare a function as a generator function by throwing a little asterisk before the name, as you see over here. And what that does is the function, when it gets called, it immediately returns an iterator, right? And an iterator is this object that lets us call a next method on it, right? So we can iterate through a list of things. And what are we iterating through? It's whatever this function yields out. So here we have two more quotes that are awesome. You can read them. But we're yielding them, okay? And what this means is that when we have our function here, we're going to call getQuote. It's immediately going to return that iterator. And now we can use that iterator. So we come down and we call the iterator, and we call next on it to get the first yield. And then we're going to grab the value out of it. And the value is just going to be the quote that it yields, right? So we call it once. Then we just print out blah here. And then we call it again, right? And we can see, don't look at that yet, right, that it prints out in the order we expect, right? But this is starting to look synchronous, right? To me, this is synchronous. We're calling our function. It's not fully executing yet. It's printing out the first one, then we run this other code that happens, and then we can follow up with the second yield, right? So we're moving towards a more synchronous approach to doing async. How we can use these in going forward with like network requests, it's really complex. You have to wrap it in a function that spawns another function that can give you the iterator. Definitely go read about it if you're interested. Jimmy, who the talk that I saw at the Node.js talk, he's an expert on this. He's the one who taught me a lot of it. So hit up Jimmy for a good explanation. But I wanted to touch on it because it is important. So as we're moving towards more synchronous code, right, we're approaching the apex, right? And as in this GIF, we see this awesome basketball player who is just king of the world, right? He's obviously like, who's going to win the game? There's no contest when it comes to this. So that's what we're approaching in JavaScript. So everyone's familiar with the ES6 proposal that's been standardized and finalized, and we're starting to see cool things roll out. Node 4.0 came out, and it brought a bunch of ES6 features. Browsers are slowly rolling them out. What I'm talking to you about now is actually an ES7 proposal. And this is a proposal that's going to be part of ECMAScript 2016, right? So it's hopefully going to be finalized next year. And this is the asynchronous functions proposal, or async await, as it's also called, right? So what we have here is it's a new concept. It's sort of reminiscent to generators. It uses promises heavily. So we are doing the same kind of thing. We're requiring requests. We're defining our function. We're returning a promise. Nothing's changed over here. But in our main function, you can see that there's a couple new keywords. And I can't make it any bigger, right? But we're looking over here, and this function has an async before it, and it also has an await here, right? And what does that actually mean? Before we explain what it means, we're looking at this code, and this is synchronous, right? This is what we tried to do before. Right. We were trying to call getQuote and return it into a variable and then print out that variable. And we're actually able to do that with asynchronous functions. So when a function's declared async, it's allowed to await a resolved promise. Okay? So the getQuote function returns that promise, and we're allowed to await for it to be resolved or rejected before we progress. And the execution in our main flow continues as it would, right? So you can see down here that we call our main function, and then printing out Ron thinks that, and we see over here, it prints out Ron thinks that turkey can never beat cow, right? But this is awesome. Who thinks that this is awesome? Because I do, right? We've taken our asynchronous code that tripped people up before, and we've made it so that we can think about it synchronously, right? We have a firm understanding of promises. When the promise is resolved, we can just wait for it to finish whatever request is happening. And this is cool. The couple caveats are, I know you probably noticed we had this main thing going the whole time. You probably don't use a main function normally, but you can't await in your main context, right? So that's why we have to wrap these things in a function. But we're able to use this today with a transpiler called Babel. Has anyone heard of Babel before? It's kind of the new hotness right now. Babel let us take our ES6 or ES7 code, compile it down to ES5, which can run just about anywhere. So Babel has support right out of the box for asynchronous functions. So the next time you're wanting to try around and play with something, it's currently in stage 3 of the draft proposal, which means it needs feedback. So if you want to go ahead and play with it, feel free to go to the proposal page and open a GitHub issue if you have problems. But this is cool. And this was not something we had before, right? So we're talking about errors again. And now we're handling errors, right? So how much repeated code is in here? Right? We have the same thing that is called every single time. If error, we're going to deal with the error, right? We should probably be returning to break out of the loop. But this is awful, right? This got worse than before. The cool thing about asynchronous functions is we get to take back a very important programming structure known as the try-catch block. Have you guys used the try-catch block before? Probably not. It's really rare that you use them nowadays in JavaScript. There really wasn't much use for them because everything was asynchronous callbacks with the error passed in, right? But to give you a better understanding, this try-catch block construct, so in many other languages like Java and C# and just about everything has some concept of a try-catch, right? So we declare a try and we execute a statement in here. And any errors that are thrown, right? So you can throw an error that we create as opposed to just passing into a callback. Any errors that get thrown or returned during this execution get caught in the catch block. And it stops executing the try and immediately jumps into the catch, and you can deal with your error there, right? But this is not something that we had access to before. And I'm pretty excited for this. This is synchronous code. Right. We're looking at this code, and this runs exactly as you expect it to. We're able to use things like return statements, try-catch blocks. This is the epitome of asynchronous in JavaScript, right? We've reached the end of the road. If someone comes up with something better than this, I'll be very impressed. But I think this is awesome. And what we're looking at here is actually an example of using the Twilio library, right? So anything that returns a promise out of the box, we can take advantage of. So Twilio, we're a communications company. We have APIs that let you send and receive text messages and phone calls and do some cool stuff with video. So what we're doing here is we're actually just sending a text message. And this client.sendMessage function returns a promise, right? So we're immediately, without any other gimmicks, able to just await it, right? And it returns a response inside the promise resolution. And then as soon as that's done, we can say, hey, the request was sent. Here's the request ID. If it failed for some reason, it prints out that error. And we see here that it's really hard to see, but this line printed out first, right? So I print out first to show I'm async. Then it prints out request sent, and then it prints out the request ID. So out of the box support for anything that it's already using a promise, right? And this is really awesome synchronous looking code. I already talked about Babel. You can go download Babel. You can use this today. You just throw Babel compile at it or Babel-node. It gives you a binary. It's pretty awesome. And that's it. That's all I have. So thank you for having me. I'd love to answer any questions. I know we went through a lot of stuff.
All right, if anyone has questions, let me